All right, so I'm going to share the screen. Um, 9, 4, number 11. Find the area of the region. We've got two polar curves, 10 plus 10 sine theta, and then r equals 30 sine theta. And we want outside the first one, but inside the second one. Now, probably like me, you probably have no idea what this thing looks like. So let me go. I'm going to go to Desmos now. So give me a moment here. Let me share the screen again. There we go. You should be able to do polar just by using the R and theta nomenclature. So we get looks like a cardioid. And the second one is R equals 30 sine theta. It's just a circle. All right, so we want it inside the circle. So I guess what we want is inside the circle, but outside. So we want this moon-shaped region up top, the part that's between the 20 and the 30. Um, so that gives us a clearer picture of what we're looking for here. Okay. So your question was setting up the bounds, correct?
Correct.
Okay, so we need to figure out where they actually cross. So we can set them equal to each other. The two are, so we have 10. Oops, my bad. The We have 10 plus 10 sine theta equals 30 sine theta. If I do a little bit of manipulation here, I subtract out this 10 sine theta, I get 10 equals 20 sine theta. And I divide about 20, I get 1/2 equals sine theta. And then I basically arc sine both sides. Um, well, you're going to get two answers. It looks to me like one of the answers, well, sine of pi over 6 gives you 1/2. So one of the answers is pi over 6. And then we have to figure that the other answer is going to be, looks like it's going to be 5 pi over 6. So almost all the way around. Okay. Let me go back to the Desmos screen again. If I click on, I didn't do it. So I thought you maybe could click on the curve and it'll tell you the point. Um, Not being able to do it. So, okay. But this seems correct. So in other words, at the angle pi over 6, that's this angle right here, 30 degrees, and that's when the two regions overlap or the curves intersect, and then it comes back down to 5 pi over 6. So these would be your bounds. Now we're not done with the problem, of course. This just gets us the bounds. So pi over 6, 5 pi over 6. Give me a second here. I'm going to do something. Okay. Let me pause here. Thomas, that was your question, right?
Yes.
Does that help explain how the bounds were found?
It does, and this may just be like my brain not working properly in this case, but like how, like you knew that the arc sine of 1/2 gives you pi over 6. Like,
Right.
are these things we're just supposed to know, or is there a way to find that?
Well, you could do it on your calculator. I mean, just enter in sine inverse 1/2, make sure you're in radian mode, and you'll just get a decimal quantity, which will be equivalent to pi over 6. Um, yeah, you should know your first quadrant values. And then from that, you should be able to infer their reflections in the second, third, and fourth quadrants. So you could get away with just doing this on your calculator. You should algebraically be able to get to this step right here. And then you can use your calculator to get a value that'll give you this value here. In fact, I'm going to try it on mine. You have to be in radian mode. Um, so if I typed in inverse sine of half, I get 0.5235998, blah, 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 which happens to be pi over 6. So it'll give you the correct answer. It just won't give it to you in that nice nifty pi form.
All right, thank you.
Sure. As far as setting it up goes, if you want to, I'll just go ahead with the setup. The general form for area within a polar function is that it's the 1/2 on the outside, and then you square the function on the inside. So we would want to square the quote bigger function. It would be the 30 sine theta quantity squared, and then subtract off the smaller one, which is the 10 plus 10 sine theta quantity squared d theta. And as far as working this out, yeah, it doesn't look too bad. I can get a couple steps. I don't know. I'm kind of already rolling on this one. Um, this would be 900 sine squared theta. And then here we're going to have negative 100. I have to remember I'm pulling the negative in there. And I'm going to have negative 200 sine theta. And then I'm going to have negative 100 sine squared theta, all d theta. And then I can combine the sine squares. I get 800 sine squared theta minus 200 sine theta minus 100. That's not too bad. Actually, this one's working out pretty nice. As far as working this out, one thing you definitely guys want to know is know your sine squared, your identity, because you can't integrate that directly. And the sine squared is 1/2 minus 1/2 cos 2 theta. So one more time, um, I'll just write out the integral. If I distribute that 800 through, I get 400 minus 100. So I actually get 300. And then I'm going to have 400 cos 2 theta. Then this guy doesn't change at all. And that's not a bad integral. These will work out. This is just 300 theta. Um, this will be 1/2 sine 2 theta, so that'll make a 200 in front. And then this will be actually plus 200 cos theta. Yeah, it should work out pretty nice. Does anybody want me to complete that, or are you good to go on this one?
I'm good.
You good with that?
Yes, sir.
Anybody else have any questions on this one? All right, I'll tell you what, I'll leave this one where it is. The rest of it's just usual, evaluation. Just make sure you don't mess up a negative sign, that kind of thing. All right.